Now we're going to be checking for nitrite toxicity in the water and also chloride concentrations, which kind of go hand in hand. The chloride concentration in the water protects the fish from the nitrite in the water. But first of all, here we'll talk about the nitrite, and then we'll kind of proceed into the chloride test. To test for nitrite, we need to fill up the syringe with 10 cc's or 10 milliliters of the tank water. Put 5 cc's or 5 milliliters in this test tube and 5 in this. This tube will just leave blank. We won't add anything to it. But this other tube, we will add Nitrovair 3 powder pillow to that one tube. And after we add this powder from this tube, I typically just tear these open, but if you have difficulty doing that, you can use the clipper that comes with the kit. And then I just push the little cellophane powder containing packet open and pour it into the tube. And so you don't get your fingers exposed to this chemical, you can use the plastic cap that comes with it. Or if you have vinyl gloves like I have on here, nitrile gloves, latex or whatever type of gloves, you can use that. And then shake it up real well. I think the instructions say to shake it for a full minute. I typically shake it a little bit less than that. And then we'll leave that to develop, for that color to develop over the next 10 minutes. For sake of time, 10 minutes ago I ran this test, this same test, using that same type of powder pillow for the nitrite, and this is the red color that develops after 10 minutes. You can see the one that we just did is starting to turn red already, but it's not quite ready to read. For the nitrite test, we will use this red color wheel here in the box, and we'll put the red sample on the right and the blank sample on the left. And I like to hold it up to two different lights, a fluorescent light in front of me, a fluorescent light in back of me, and then match up the colors. Okay, in this case here, the color is so dark that it can't be read by the wheel. So what we have to do is make a dilution. And let's see, I need to get some deionized ammonia-free water. What we can do here is we will take this empty test tube here and we'll add 1 cubic centimeter of water, and we can use this to measure the 1 milliliter or 1 cubic centimeter of water. Okay, so we'll put this 1 milliliter of the test solution into this test tube here, and then we'll add 4 milliliters of ammonia-free water, and we can take the syringe and measure out 4 milliliters of the ammonia-free water and add this to the 1 milliliter of that original test. And you see it dilutes the color so that we can get an accurate reading with this color wheel. And again, we'll put the blank in the left, and we'll match up the colors here, and it's a 0.14. So when we have the 0.14, that's not exactly our milligrams per liter in nitrite. We have to remember that we cut that solution by 5, so it would be the 0.14 times 5, and then times a correction factor for the nitrite test, which is 3.3. So we take the 0.14 times 5 times the 3.3, and that gives us the milligrams per liter or parts per million of nitrite. So in order to protect the fish from this toxic nitrite, we need to have enough chloride ions, enough sodium chloride in the water to protect the fish from the nitrite toxicity. So now I can run the chloride test. Okay, and so we can get a calculation of 0.14 times the 5 times the 3.3. So 0.14 from the color wheel times the 5, we cut it 5 times with the dilution, and the 3.3 conversion factor, and we'll get that number 2.3 parts per million or milligrams per liter of nitrite. We like to always have at least 10 times more chloride in the water from a salt source to protect the fish from 10 times more chloride than nitrite to protect the fish. So we would need at least 23 parts per million of chloride in the water. So let me go ahead and run the chloride test here. This chloride test that we've developed differs from the test that's in the FF1A manual, and we have a flow chart that you can refer to on that. But what we do is we take the tank water, and we use 46 milliliters of the tank water. This little bottle that comes in the FF1A test kit has increments marked off. This has 23 milliliters marked off at the top there. So we'll simply fill that up twice to the 23 milliliter mark. And we'll put that in, we'll use this empty beaker here. And we'll do that one more time to the 23 milliliter mark. So we have a total of 46 milliliters of water. And then we'll add one chloride 2 indicator powder pillow. And this came from this packet here. We'll open this up. And it will turn kind of a brilliant yellow color. And then we titrate this sample with silver nitrate. So when I say titrate, we simply count the drops of the silver nitrate that it takes to turn this bright yellow color into kind of a dull yellow, orangish color. So 1 drop. You see it's still that bright yellow. Drop number 2. It's still kind of a bright color. Drop 3, 4, 5, 6. Not quite there. 7. Now I would stop there. It's not bright yellow anymore. So 7 drops. And in order to be a little bit on the conservative side, we don't want to overestimate the amount of chloride. We want to add liberally with salt. So we take those 7 drops and we subtract 1. So we get 6 drops, and we'll multiply that times the 3.8 factor for the chloride test. So 3.8 times 6 drops equals 22.8. Okay, so we'll just round that off to 23. So we want to add 23 milligrams, or I'm sorry, we have 23 milligrams per liter of chloride in this water. And so looking back at the nitrite that we got a 2.3 parts per million nitrite, and we actually have 23 milligrams per liter of chloride. So in this case, we're actually protected adequately by the chloride that's in the water. Now, so our chloride concentration was 23 milligrams per liter, but I like to recommend that people maintain at least 100 parts per million or 100 milligrams per liter of chloride in the water, just as a preventive type measure in case the nitrite unpredictably shoots up. So I like to recommend just if you have a tank of fish, make sure you have 0.63 grams of salt per gallon, and for every and that would put your concentration of chloride at 100 parts per million. So 6.63 grams of sodium chloride salt per gallon, or if you measure your tank in cubic feet, 4.7 grams of salt per cubic foot, and that will give you 100 parts per million of chloride. Okay, and if you have a nitrite concentration that exceeds 10 parts per million, see the 100 part per million chloride will protect you up to 10 parts per million of nitrite, then you can add more salt to the water to protect the fish from that even higher amount of nitrite that could occur in the water. So thank you for your attention. If you have any questions, please contact myself or Kat Mitchell at Kentucky State University Aquaculture.